All right, completely changing gears. This time I want you to verify that this infinite series converges. In 9.1 we were talking about convergence and divergence of sequences. Now it's going to be series. So what does this add up to? You may or may not want to write this part down, the part that I'm doing in here in blue. If I plug a 1 in to both of these, it'll be 1 over, let's see, 4 times 6. Plus, because remember, sigma is sum. These are all going to have 1s on the top. Again, I don't have to write this blue stuff. I'm just doing it as a teachable moment. If n becomes 2 and you plug a 2 in, it'll be 5 times 7. If you plug a 3 in, the numbers just keep going up by 1, so that's 6 times 8. You can see that this is shrinking. It's definitely shrinking, so it seems like it's going to converge. Well, it will converge because I said, hey, verify that the series converges. I'm telling you it's going to head towards something. And since it heads towards a number, that means that it should add up to a sum. We're going to figure out the whole thing. We're actually going to find the sum of this. And we're going to use something called a telescoping series, which is the header of this day 1. So I'm actually going above and beyond my own directions. Not only am I going to verify that this converges, I'm going to find its sum, and I'm going to sort of explain it as I go. First of all, I sense partial fractions here. Even though I'm not integrating, I can still use partial fractions to my advantage using sums. Okay, so the partial fraction has been set up. Again, it's just simply a sigma instead of an integral symbol, but everything else is the way we're used to seeing it. And we need to get our common denominators, as always. A pair of n plus 5s for the first fraction, a pair of n plus 3s for the second fraction, and all three denominators have now been made common, which means the numerators need to match as well. And now they do. All right, let's let n be -3. That'll knock the b's out. It'll be b times 0. And it will give us 2a equals 1. So a will be 1/2. All right, now let's let n be -5. If n is -5, that'll knock this part out, and you'll have -2b equals 1. And not surprisingly, b is -1/2. After all, we had a 1 up top, which was a constant, so I knew that a and b were going to be opposites. All right, I'm going to rewrite the summand now, which is the name for the thing after the sigma. I'm going to rewrite the red summand, get rid of all the greens. And since a is 1/2 and b is -1/2, I'm going to place those in as well. All right, one more thing I think I'm going to do. I'm going to factor out a 1/2. I'll do so in blue. That'll turn these into a 1, and this will become a -1. In fact, I'm going to write the negative right here in the middle. That works because, if you're doing a sum and you're adding this up, and there's a 1/2 in front, the 1/2 is just going to distribute through to all the terms. Even if it goes on to infinity, that distributive property will still, deal the 1/2 to everybody. So you're allowed to factor through a sigma. That's always okay. It's just like having, a factoring outside of a parenthesis. Nothing wrong with it. Okay, I rewrote this just so it doesn't look so chaotic. It looks a little nicer here. In fact, you know what? I'm going to erase all the craziness and just put that in its spot, just so I have plenty of room below to work with. Man, that looks so much nicer. All right, let's try out the 1. We're going to plug that n equals 1 in and just see what happens. That'll give us 1/4 minus 1/6. Let me write that down. I could subtract, but I'm going to wait on that part. Okay, plus. It's always a plus because remember we're dealing with a sigma. That means sum. We're adding. All right, let's say that n is 2. If n is 2, the first fraction is 1/5 minus 1/7. Okay, so far so excellent. Plus, because again, sigma, sum, addition, You get the gist. And so forth and so on. All right, if n is 3, here we're going to have 3 plus 3, which is 6, and 3 plus 5, which is 8. Yeah, let's do one more. Then I'll go dot, dot, dot. You get the idea. I don't have to insult your intelligence by talking at you slowly. It's 1/7 minus 1/9, and then 1/8 minus 1/10, and so on and so forth. Interestingly enough, this positive 1/6 right here will cancel with the minus 1/6. Those are gone. By the way, all these red parentheses I'm writing aren't really doing anything. They're just there for show. You can get rid of them if they're bothering you. This 1/7 here and the negative 1/7 they're going to cancel out. They add up to 0, so they're gone. This negative 1/8 doesn't seem like it has a partner, but if I kept the parentheses going, it would have a partner. This would be 1/8 minus 1/10. So that's gone. The negative 1/9 will cancel with the 1/9 in the future. Everything else is going to cancel from here to eternity. The only things that survive would be the 1/4 and the 1/5 there in red. Have you ever seen like a collapsible antenna that you can either make real long or real short? Or like a selfie stick. How people hold the selfie stick out in front of them and they can take a large group picture. Those are called telescoping antennas. And this series just telescoped down. This thing went all the way out to infinity, but because of all the canceling, it retracted down to like 2 terms, 1/4 plus 1/5. That's why we call these things telescoping series, with all the canceling. Well, 1/4 plus 1/5, if you get common denominators on those, it's going to end up adding up to 9/20ths. Which makes the final answer 9/40ths. All right, number 4, same set of directions. We're going to, again, overachieve, and we're going to not only verify that this converges, we're going to figure out what the sum actually is. This time around, I'm going to factor out the 5. I didn't do that last time. You're allowed to if you want. Just for variety, what the heck. I'll make that a 1. This still factors, and so you can see the partial fractions forming. Let me go ahead and do that now. All right, I'm going to get common denominators, as I always do. A pair of n plus 2's for the first fraction and a pair of n plus 1's for the second fraction make all 3 common denominators, just as I would hope. All right, that allows me to make the numerator equation. All right, there we have it. Remember that it's equals a 1, not 5. The 5's been factored out. The 1 is what we're using to match this stuff here. The 5's already are out there, apples to apples. So, all right, we're going to let n be negative 1, and then we'll turn around and let n be negative 2. I already know that a and b are going to come out opposites because 1 is a constant, but we'll do them both. If n is negative 1, then of course that's going to be b times 0. And that'll leave us with 1a equals 1, so just a will be 1. And then, of course, if n is negative 2, that'll make that a times 0. So you're going to get b times negative 1, or negative b equals 1. So therefore, b will be negative 1. Again, a and b are opposites. All right, I'm going to go back up here to the red to get all the black and green stuff out of the way. We'll replace the a with 1 and the b with negative 1 right now. All right, 2 things. I'm going to create some workspace, and I'm also going to change that plus negative 1 just to a minus 1. Just right here is what I'm talking about. All right, now I'm ready to go to work. Let's figure out what this converges to. If you send the 1 in, you're going to get 1/2 minus 1/3. Those denominators are only 1 apart, which means the canceling is going to come on a little sooner than before. All right, if n is 2 and you put it in, you're going to get 1/3 minus 1/4. The canceling is already apparent. These are going to cancel out. Let's just do one more. You get the idea. It's going to be 1/4 minus 1/5. And that'll continue on forever. 1/5 minus 1/6, and so on and so forth. And the canceling continues to happen forever. All that's left is just this 1/2, and of course the 5 that I initially factored out. And so this is going to converge to 5/2. All right, one more, slightly more difficult, but not too bad. Again, I like to factor the 2 out. I thought that worked pretty well last time. All right, here we go. Let's do some factoring. I got n plus 4, n plus 7. All right, let's get common denominators. We need them all to be n plus 4, n plus 7. And that's looking good. All right, let's get the equation from up top. All right, setting the numerators equal to each other yields that. We're going to let n be negative 4 and also negative 7. If n equals negative 4, of course, you get b times 0 here. Plugging the negative 4 into the first parentheses is going to be 3a, and that'll be equal to 1. So a will be 1/3. I'm fully expecting b to be negative 1/3 because, again, the 1 up top was a constant in the numerator. Let's see if that works. If n is negative 7, then you'll have a times 0. Plugging the negative 7 in here is going to give you negative 3b equals 1. So sure enough, yeah, they're opposites. All right, so I'm going to replace the a and the b with the 1/3 and negative 1/3 once I clean house up top there and get rid of the green stuff. Okay, so a is 1/3, b is negative 1/3. To make my computations a little more easy later on, I'm going to go ahead and factor out a 1/3. In other words, I'm going to multiply the outside by 1/3, which is factoring. I'm going to multiply the inside by 3, which of course is just going to make this a 1. It's going to make this a negative 1. And that's what I want. That'll be a lot easier. And instead of having a blue 2 out front, I'll have a 2/3 out there. All right, I'm going to rewrite this a little bit more neatly. And now we'll go ahead and we'll start plugging in the 1s, the 2s, the 3s. We'll see what happens. All right, we're going to start by plugging the 1 back into both of those. Okay, again, we still have a 2/3 out front. Plugging the 1 in will give us 1/5 minus 1/8. Very good. Plus, because again, it's a sum. Plug in a 2, and the denominators just rise up by 1, so you have 1/6 minus 1/9. Repeating with a 3 is going to give us 1/7 minus 1/10. One-eighth minus 1/11. And at this point, you can start to see that the canceling is taking shape. I can see that the 1/8 has a negative 1/8 to cancel out. This next group of parentheses that I didn't write will start with a 1/9. That's going to cancel the negative 1/9. Anything after this negative 1/8 that has a larger denominator like 9s, 10s, 11s, they all will have canceling partners. In fact, the only 3 that are left are the 1/5, the 1/6, and the 1/7. And to be honest, I knew there were going to be 3 of them left because if you notice, once you factor, the 4 and 7 are 3 apart. So there are 1, 2, 3 items that remain once you telescope. In fact, if you go back to the other problems, you can see that's true as well. Let's take a quick journey. These 2 were 1 apart. There was 1 thing that survived. It's nice to know. That way you don't lose anything in your work. The two factors were 2 apart, and sure enough, you can see that there were 2 green circled items that were left over. So again, that's kind of cool to know. So I kind of know what to expect as I'm doing the partial fractions. All right, that just leaves this algebraic mess. There's a 2/3 in front still, and 1/5 plus 1/6 plus 1/7. Thanks to my calculator and the math fraction thing that I have is 107 2/10. Of course, you can cancel the 2 even numbers. 3 times 105, that'll be 315. And yes, this sum converges, and it converges to 107 3/15.